there's some error. Hold on. All right, now we're live. All right. Hello, everyone, and welcome to this week's GPTScript live stream. It is great to have some excellent guest speakers today joining Darren and I. So today's focus is going to be on really how to use AI and GPTScript in your day-to-day job as a DevOps engineer. And to tackle that problem, we have two really great guests joining us today. The first presentation is going to be from Jared Sutton, who's the managing director at OppStack, a consultancy that focuses on things like enterprise IT operations, security, standardization, automation. Jared, you want to maybe just introduce yourself really quickly?
Sure. I'm a managing director at OppStack. I've been working in and around IT and being in some manner of on-call for going on 20 years now. I've done cloud and on-premise DevOps and automation, systems administration, et cetera. And so here for the past 5 years, I've been working at OppStack doing consulting for teams that do what I used to do.
Awesome. And your demo today is going to focus on AWS, right? You're going to talk about kind of monitoring alerts in AWS and how to use AI to assess those.
That's right. So this is kind of a tech demo to explore the notion of using something like GPTScript to bring an LLM into your cloud environment and let it assist you with systems administration tasks. And as a tech demo, sort of pushing the boundaries of what both GPTScript or GPTScript coupled with LLMs can do. And so we'll talk a little bit about the implications of that afterwards and where we would go from here.
Awesome.
So to go ahead and kind of get started, right now we've got a cloud environment. We've got a CPU utilization graph that's hooked up to an AWS instance. And we can see that right now the instance is essentially doing not a whole lot. We're about to start and stress out this instance. So what I'll do is I'll switch screens over here.
You might need to share your whole screen and then go back and forth once you're there.
All right. So we have our AWS instance, and we can see that it's under stress. So we've applied a stress program to it, and I can do. Let's switch this out one more time. And switch to the screen. Okay.
There we go. That's all your different screens are.
Right. So what we should see now is our instance will go under stress, will trigger our alarm, and then we'll see something else happen. All right. So now we see our instance.
This set up just so we're kind of setting the stage a little bit. This is an EC2 instance you're running in AWS, and you've got CloudWatch configured to monitor it for CPU utilization in this case?
Correct. Yep. So our EC2 instance that we just looked at that's under stress is running in EC2. We have this CloudWatch alert set up. The CloudWatch alert will fire. And when it fires, it will send an event to AWS Event Bridge, which will then fire off an EC2 or an ECS task. All right. So we can see we're now in alarm. If we hop over to our ECS cluster, we'll see that we've got a new task in the provisioning status. And once it starts running, it takes about 40 seconds, and then we should see a change happen in our EC2 instance.
And what's this task doing, Jared? Can you explain it?
So this task behind the scenes is running GPTScript as an automatic systems administrator. And the goal that we've given GPTScript is to log into the instance and attempt to resolve the issue that has been given.
Got it. So it's basically, this task is a Docker container running GPTScript as just an engine, and then
that's right.
You've got a GPTScript you've already created that is what you've just directed it to assess the impact of this stress on the system, for example.
Correct. Yeah. So we've sent over basically what the GPTScript gets in order to resolve the issue is it gets the alarm name and the instance ID, and from that it has to collect the rest of the information that it needs and then resolve the issue. And we can see right there that our machine is no longer under stress. So we've dropped that. And if we hop back over to here, we'll see our task should complete. All right. And so then if we look at our task, it's just completed. You can look at the logs. There we go. And we can see that it's provided us with a diagnosis. So it said the high CPU usage was caused by stress, which was consuming 99% of the CPU utilization. It's taken steps to resolve it. So it identified the issue, and then it ran the kill command on the stress application, resolving the issue. So if we look at the GPT script itself, we can see that what we've given it some tools and some instructions. So we've given it the ability to get environment variables. This is how it receives the information from the event bridge. We've given it the ability to get an instance IP, run an instance command, and then check a port available, check whether a port's available or not. And we've prompted it that it's just received an alarm. And here's the two pieces of data. It gets the name, which would be AutoSA CPU, and the instance ID, which is a normal EC2 instance ID. We ask it to retrieve the IP, determine which IP to use, because there's both a public and a private side. Then SSH into the instance, try up to 5 diagnostic commands, and then attempt to resolve the issue and output the diagnosis if any steps are taken to resolve. And for our get instance IP, we're just giving it describe instances. For the run instance command, we're just sort of setting up SSH so that it has an easier time of running SSH. And then check port, we're just doing a quick check against dev TCP to make sure that it can determine whether to use the public or the private IP. This tool gets run by an entry point that we set for our Docker file. And all we do here is we grab the SSH key out of system manager parameter store, apply it to the system whenever the container starts up, and then we run GPTScript using the GPT-4o model. Although it was originally built on GPT-4, just 4o makes it faster and cheaper. And then the Docker file, we just grab a basic Amazon Linux container, install GPTScript, add the tool on the entry point, and set the entry point. The actual ECS instance itself is configured using a tool called AWS Copilot CLI, which is not to be confused with either GitHub Copilot or Microsoft Copilot. This one was the first one.
Yeah, this is the OG Copilot. Yeah,
the OG Copilot. That's right. And so, notably here, just from how do we wire this thing together? We've got a manifest which tells us that we're going to use our Docker file. It sets CPU and memory, and then we define some secrets that we're going to give it. So one of the secrets is an OpenAI API key, and then our SSH key. And so we're able to set these at deploy time so that these are available for the task to use whenever it starts up. And then we've given it the container itself an access policy that allows it to describe the instances. And so in this way, we can have a container that starts up. It has exactly what it needs and no more additional permissions. Although granted, we're giving it quite a bit of permissions to run on this one EC2 instance. We are actually sort of constraining what it's allowed to do. So that is the end of the sort of the demo piece. Looking at where do we go from here from a tech demo? Because like I said, this is intended to be a showcase of what sorts of things are possible. Like, what do we do if we give GPTScript the minimum data that we can? How far can it go? Where you would likely take this from here, if you wanted to try to use this in some sort of a real scenario, is the first thing you would do is you'd probably look at making it constrained in what it could do. So you might build some Ansible playbooks and constrain the actions that you allow it to take on the remote system. You might constrain the actions that it's allowed to take to read-only operations. You could use the AWS system SSM service to run predefined commands. So you might say, you don't actually get access to SSH into the machine. Instead, here are the things that you can do on the remote machine and to attempt to diagnose the issue. Or if you wanted to pull this out of AWS, you could actually have another monitoring system, let's say SignalFX, CoreLogix, or even Nagios, that could actually fire up GPTScript and have it run. And instead of SSHing directly into machines, you could have it interact with a tool like Ansible AWX and hit the API on AWX to allow it to run specific commands against a remote host. So there's a lot of different ways you could sort of wire this together. The one that I chose here today was to take CloudWatch, which a lot of cloud deployments we see have alerts that people already have, and it allows you to essentially tap into those alerts that are already flying across, and then allow GPTScript to take actions that are well known. A few other things that you could potentially do that I've seen some companies do is provide information in the alert, so in the description, that say things like, here's the runbook for the service. So alongside, you can provide additional context there, at which point either shipped with GPTScript or it can pull it at runtime. It could pull the runbook in and actually take actions based upon that. The other thing that you could do is ship it with a knowledge database file, so that you could have the GPTScript fire up and be able to make calls to the knowledge tool to pull in the runbook and take actions. And that would make it faster, right? Because you don't have to reach out. You don't have to have external connectivity. You can say, here's, like, I'm shipping GPTScript with a full-on knowledge base of all my services. Now it gets an alert, and here are the actions that we're allowing it to take. So those are some of the ways that you could extend this and put this into environments where you might feel more comfortable, let's say, running it in a production context or even in a non-production environment. Because you probably wouldn't just go throw this out into your production network and say, hey, GPTScript, go fix my stuff for me, without having added some constraints around it.
Yeah, this is so cool. I mean, I've been fooling around a lot with GPTScript recently of applying it to various DevOps tasks. We spent the last couple of months kind of building up GPTScript, like the core of it, and then I've been playing around the last couple of weeks, like a lot with Kubernetes, but also doing things with AWS, because I've been trying to do like EKS. And this is so cool because you find that the LLMs like GPT-4o or GPT-4 in general already knows AWS extremely well. And it's very good at troubleshooting basic things. And like anyone who's done, kind of operations knows that it's like 90% of your issues are actually kind of basic. It's just kind of troubleshooting and figuring out. So it's like I've been super impressed with like its ability to just kind of do some troubleshooting, go through the steps. It kind of comes up the plan that you showed, like it decides like, oh, I should check this, and then it goes and does it. But like the biggest concern everyone has about it with AI is like trusting it. It's like, what is this thing going to do? But that's what's also amazing about the current state of, like, let's say AWS or infrastructure in general, is you already have these like really rich RBAC systems where it's like, yeah, you don't trust it, but you have all the ability to constrain it. So it's just like, okay, because like what you can do also is like, just don't do auto remediation, because a lot of people won't trust that anyway. So it's like, but just the thing of like, if you could run that task, go through, and it goes like, look, this is what I think the solution is. And then if it can just, fire that off, so human can, so then at least you have like, look, there's an alert, and this is what we think is the suggested solution. That immediately, and then if you trust that enough, then you can let it remediate it. Or as you said, you can just give it where it's like, because it's the same things you do to operations for your like kind of like more like level 1 support or something like that. It's like you give them the button where they can restart. It's like you give them kind of the harmless thing that they can do to maybe fix it. So you can give that to AI and say like, well, you can try that. If it doesn't fix it, then escalate it.
Yeah, the intent was actually to sort of emulate a level 1 knock, knock person. So the kind of person who sits in the knock at 1 a.m. in the morning and something goes bump in the night, and then you give them a set of things that they're allowed to take action on. I used to get, a long time ago, I used to get calls at 2 a.m. in the morning from a development, division of the company that I worked for that was in Lebanon, and they would call me and tell me that the development server had filled up its disk space again, and they wanted me to like fix the issue. And so I would, do my best to answer the call and act as though I were completely awake, but when in fact I was in some stage of consciousness.
Yeah, I mean it's super cool. And then what I like about this, because like it's like if you look at that GPTScript which you wrote, it was actually the majority of it was kind of like the plumbing of like a little commands, but the actual kind of logic where you're like, well, do this, and this is so simple. It's like just a couple lines. But the thing is like, it already knows kind of these infrastructure systems so well, But then with a very small amount of information and prompting, you can kind of guide it to your specific flavor on how you're doing it, because there's a million different ways you can use these tools like AWS, but you can say like, look, like we prefer this, so it's like, you just give it a little guidance of kind of what makes sense for your context. And I've been super amazed at this, at like, I've been fooling around with Kubernetes stuff of just like, the thing that I've been most amazed at is troubleshooting, is like just letting it try to figure out what the problem is and letting it run more commands to interact and like discover more information. And it's been amazing. It's cool.
Jared, when you think of other places to apply this, I mean, could you see this working well for other, network analysis, DBA type work, potentially even application development sort of troubleshooting as you get into app level functionality problems? This is sort of fixing a hung process, feels like kind of the lowest hanging fruit and really straightforward, but it seems like, at least with the troubleshooting kind of approach that you both talked about, that seems like you could really apply pretty broadly to initially kind of entry level analysis, and probably something that's just going to get better and better as time goes on.
Yeah, I think there are three areas that you sort of sit in that could be like readily applicable. So the first would be CI/CD stuff, like or the meat and potatoes of like DevOps stuff, like CI/CD system. So like auto remediation of CI/CD issues, like, oh, the build broke. Why did the build break? Especially like for a developer, like, so if you're a DevOps person, you've got like, let's say 6 development teams, and one of the developers broke the build, having an auto SA or, sort of an auto DevOps person or, program that they can sort of use to help resolve issues like you broke the build, is one really powerful application of it. Another would be cloud operations. So things are all over the place in AWS. And so having a tool that can pick up and either try to auto remediate or at least diagnose the problems that you're seeing in a given cloud environment. So basically the same thing that we did with the EC2 instance, but just in AWS services. And then the third area, which sort of sits right next to a NOC, would be a SOC, right? So SOC level 1 analyst. So security incident happens. You can have, I think you could very easily apply and sort of tweak this notion to sit in a security operations context and take in information about incidents that are happening, and collect and enrich those incidents, and even push them along part of the way through the incident resolution process, for well-defined things like unlikely user login. Somebody logged in from Massachusetts and Shenzhen at the same time. Like, okay, well, we know pretty well how to handle that. Let's say that the issue is always disable the user account. So you can have an automated system that evaluates, gathers data, and then takes an action as a result on that. Some of these things can be already done via just simple shell scripting. And so I think the really interesting part is to figure out what are the things that you can't really readily do with a shell script today, like regular logic that require a little bit more diagnosis. And those are the areas where I think this can be, you can actually see some real use cases in.
It strikes me that we've been talking about, I think all 4 of us have worked in DevOps now for at least 15 years, 10, 15 years. And it does feel like we've been talking about AI ops for a lot of that time. I think of all the companies that have come around, but it was predominantly alert management. Like a lot of these things were alert management and diagnostics. What's interesting is, when you go to any AI conference right now, you see so many specialty companies trying to build like, the Devin for X or something like that, like some version of a specialized model that can do this better. But what's kind of impressive about what I just saw is it's like, this is general purpose just chat GPT, OpenAI GPT 4.0 with no real, special training, no real special logic being applied using open source framework like GPTScript. The total cost of something like this should be really, really low. That incident is a tiny, that's almost nothing in terms of the cost to do it. And I wonder if, looking at the capabilities of these sort of large scale LLMs, I wonder how much they're just going to quickly be able to do everything that you can get from sort of quote unquote specialty functional, products that are built to be just for DevOps or just for DBA or just for developers. It's almost like I'm not sure there's any point in like big, because I talk to people that are making big investments in building these really specialized models and specialized tools, and I'm questioning the impact those things are going to have.
Yeah, it's really hard because like everyone, like I said, from an open source perspective, has this like desire, like everyone wants to run local models or everyone uses this open source model, and like I understand the desire and want to do that, but like unfortunately, what I've been seeing is these massive, large models are the most valuable, and I think it's the breadth of knowledge that they have because it's kind of hard, like besides just knowing a bunch of information about like, oh, I've trained it on everything Kubernetes, but like that doesn't, just because it knows everything about Kubernetes doesn't mean it has the foundational knowledge of how to actually troubleshoot. And like, how do you teach a model to troubleshoot? And like, that's the thing that's kind of fuzzy about all of this, is like, it's very hard to determine what data is actually important and what data is not important for your specific task. It's like weird, like, your understanding of abstract art for some strange reason might help you troubleshoot better. It's like, so these large LLMs, they just have this like general intelligence. And that's what I've seen as I've played with all the different LLMs is GPT-4, because it is like the one that's just kind of far out there of like the best, is like, it's just generally smarter in how it tackles things. So it's like, because I've been fooling around recently with Llama 3 70B, and it works fairly well. And it actually ends up running a lot of the same commands. And it kind of gets to the same conclusion of like trying to troubleshoot, but like the way it does it is just not as smart. It's not as like elegant. So it's like, so with the stuff that I've been seeing is like, it makes more sense to me to like just continue to kind of use these big models. These general purpose models seem to be doing extremely well. And then the other thing that's interesting about these general purpose models is because they're so smart, it takes a very small amount of information to then teach them about proprietary systems. Because like your proprietary system, most likely, it's special to you, but it's based off of a lot of concepts that are pretty general. Like your system internally can't be too crazy and wacky. It's like there's something out there that probably looks like it. So it already has something that's kind of relates to it. And so it's pretty easy. It's like, because we did that, I think we've been fooling around with like trying to see if we can get GPTScript to do Acorn runtime, like our old product, which is, we kind of assumed it wouldn't know that well, but it kind of already knows it because there's some public information. But it doesn't actually understand the GPTScript syntax. The Acorn file syntax, that syntax we came up with. But by just giving it a README, we can pretty much teach it. It's like, because it looks a lot like Q or other things that it happens to know. And anyways, so
I've seen a couple of times where it's not GPTScript, but like the LLM will make a leap. And so it's like, it's a hallucination, but like, if you think about it, some of the things that we do where we make intuitive leaps, we say it probably looks like this. Sometimes that's sort of what comes out of the LLM as a hallucination, is like the config file probably looks like this. There's probably a directive that looks like this. And sometimes it actually hits and it's right.
And what's super cool with like what we're doing with GPTScript, because we give it the ability to, because this is what I've been impressed with too, is like we give it the ability of like kind of like write a YAML file and apply it, and it hallucinates. It does it wrong. But as long as like it applies it, but then it gets an error, and then it will correct itself. It'll say, oh, that parameter is not right. Let me try this other one. And then it does kind of what a human would do, was like, well, it probably is this. And it's like, it doesn't have any documentation to look up. Like you could give it a search function. You could say like, go search the internet. But it's like, so it's kind of like, well, I think it would be this. Let me try it. Nope, that didn't work. Let me try the next thing. And it's really exciting to see how it goes through.
It really is. Jared, you built this system just on your own, kind of as you were kind of testing these concepts out. How much time did you invest in sort of kind of building this out?
I think the prototype was maybe 4 hours, and most of it was actually not the GPTScript side. It was actually, most of it was wiring together the AWS services. I spent probably a good 50% of my time trying to figure out the appropriate syntax for the rule transformation, because there's like 3 different things you have to do in Event Bridge to grab the information out of the event and then transfer it into the thing that that it needs to send over to ECS. So probably just a couple of hours on sort of testing out the different bits of GPTScript. And I think I've spent, a couple hours after that to sort of refine it and do things like, at one point I didn't have it able to determine the public or private IP to use. And so I'd actually have issues where I was using the public IP locally on my workstation, but then when I put it into the cloud, it needed to use the private IP. So that's when I added the check connectivity so that it can determine which of the two IPs it needs to use.
So funny how often that logic is derived from an error. I would say,
right.
For me, I think for everyone, is when you look at that logic, it's like, oh yeah, it errored a couple of times. There's a little bit of art to creating these things. I want to be mindful of time because Bill, I want to get into your demo as well. We only have about 30 minutes.
I want to say one last thing about AI ops, and then we can move on. Because I think what's really interesting, because AI ops was a trend before the LLM, and it didn't really go anywhere. But AI ops was very heavily oriented towards anomaly detection. It's basically trying to look at your system and then figure out how it's failing. And so I don't think that has actually fundamentally changed of how do you monitor? And because in your situations, you already had an alert which triggered you already knew CPU goes up. So it's you didn't use AI to kind of detect the initial problem. You only used it on solving the issue. Mm-hmm. So when we look at because it's what would be different if there was an AI ops 2.0? It's not so much about anomaly detection and trying to figure out what is the what's going to generate the alert, but it's on the handling. So it's the AI ops side is more kind of can I do what the level 1 support person could do? Which from everything I see, it's it seems totally feasible. The most frustrating thing to me is just it's what you said, it's half the time you spent wiring up everything else, and then there was half the time was on GPTScript. Is the frustrating thing to me is that it seems we seem to have this very powerful AI, but just connecting all the systems is what's slowing us down. And it's and so I guess that's the value of kind of GPTScript of just getting you somehow to get easy access to the AI, because it's just plugging these things in is what's kind of holding us back. It's
Jared, thank you so much, man. That was awesome.
Sure.
Thanks for taking the time, and feel free to stick around. We're going to jump into Bill's demo now. Bill is part of the team here at Acorn. He's one of our lead engineers, and also leads all of our DevOps work. And Bill's demo today is going to be focused on a chat interface he's built recently for DigitalOcean. Bill, you want to tell us a little bit more about it?
Yeah. So as Shannon said, we've been working on interacting with DigitalOcean and other systems using the new GPTScript chat interfaces that I think we introduced a couple of weeks ago. And so what we've been trying to do is work through those to see if it makes it easier to use these cloud-based systems. And so I've put together a demo here that I'll go through that's going to talk to DigitalOcean through our chat interface on the command line. It's making use of the OpenAI integration. So I've given it an API key, and I've also given it tools that are based on the OpenAI integration that we showed off, I think, a few weeks prior to our chat stuff. So it's a basic chatbot. It comes up, and now I should be able to start talking with the cloud provider. So I can say, what VMs do I have running? And so it'll go make this query, and this should give me the output that I think I've got one still running. So it gives me the information I need, and so now I can say, if I want to create another one, I can say, let's create another VM and call it Bill Demo number 1. And so what's nice about it, this is sort of actually built into GPT 4.0. Is I've noticed recently, since we've cut over to it, that it is, it's on its own personality is sort of to be helpful. And so you don't really even need to tell it, to ask for the information that it's missing. It just sort of knows, hey, I'm going to need this information. So I can say things like, let's use SFO3. And I want to use 1 CPU and 1 gigabyte of RAM, and the Ubuntu 24.
If you don't say Ubuntu right here, will it ask?
Yeah, it should. We can just see what it does there. It's pretty persistent, about what it is, what it wants. So actually it didn't, but I did have to tell it to ask about the SSH keys. I'm going to say I want to use SSH with, I'll just say that, and it'll ask me, I think, for what key. And it's going to be helpful and list a bunch of the keys that we have available.
Oh no, do we have a whole bunch of them?
These are all the public keys.
Well, I know, but I think that this is like our company account. I wonder if we have 100 keys.
No, it's not that bad. It's I think about 20 something.
Yeah.
20 exactly. So yeah, it'll list them, and then I should be able to just say, let's just say 1, because that's the key I want to use. And since I looked at the previous one, it just, I guess, assumed that I wanted to use the build Ubuntu image, but here, so it is actually, it is building it. So it went ahead and used the Ubuntu image. I didn't have to tell it. It's largely because it probably already saw that. But
how did it do the pricing?
I believe it comes back on the API call.
Oh, wow.
It's kind of fun. I can say, how much are these VMs costing each month? No, $12, which isn't too bad. But you can also, because it's got access to the other APIs, it can also do like, I want, Kubernetes clusters running. And so, it'll go and check and see if we've got any Kubernetes clusters. And if you want to build one, it's now ready to actually start building one. But I think it's probably interesting to kind of take a look and peel back what we're actually doing here and how you can go about building one. So here I've got the main entry point for the chatbot. It's just, it's the DigitalOcean bot. It's a helpful DevOps assistant. Only use the tools available and, just say hello, whatever you want it to greet with. But here we're turning on chat, and then the cool thing that we're leveraging here and, what can sort of build out the personality of a chatbot is this context. And so looking at that, each one of these, so this basically gives it the overall personality. And so here I'm specifying a certain set of tools that'll be available to everything that has this context. And then I'm also giving it a bit more consistent instructions across the board that, always delegate to the best user tool. And then, make sure you're getting the information that you need. And then always confirm deletion seemed like a good one to add.
Let me like that. So the context is kind of a more advanced feature that we've added recently. We've been playing around with. I don't know if it's been well documented. We might have documented the last one because we've been fooling around with it. But it's been seems to be very powerful because like you can share like a context with a lot of different chatbots, and effectively all the context really is it's additional system prompt. You can just give it additional information, so you can kind of share this. It's like whatever you put in that, like the sys echo there, like the output of this tool is just going to get prepended to the other tools. So like you can just kind of add more prompting to your tool, and then also what are the set of tools that are available for it. So with these chatbots, what we've figured out is like you can just kind of build this like Uber context, and then you can share it with all the different chatbots or agents. So it's kind of advanced. We're still playing around with this because I think like when when we show this context GPT, I don't think it immediately clicks what's going on. I've been kind of figuring out how to better explain it. So, but yeah, so this is like kind of advanced things, but it's proven to be extremely powerful and useful.
Yeah, it really makes these things a lot simpler to build too, and then also being able to be able to broadly change behaviors that you would want. It saves a lot of redundancy and having to type a lot too. So it ends up being super useful. As Darren was saying, this is bringing in a common set of tools. One thing about this one, just because it's using the OpenAPI integration, the size of the tool set that gets created because of the number of APIs on DigitalOcean side ends up being too large to fit into a single request to OpenAI. So what we've done is, and actually this works out as a pattern as well, like not just for breaking up tool size limits, but we create these experts or sort of domain experts or agents or copilot, however you want to call it. But it basically, each one of these is a chatbot in and of itself, and sort of focuses, you can kind of focus it on a specific set of information. So this one is the droplet manager, and so it handles all things related to droplets. It's got access to all of the APIs for the droplet. And so because of the way that we've set up the context, all of the other agents, so if I'm talking about billing and then switch context to, say, talk about droplets, it would know to switch over to this and be able to have that communications and then carry on the chat without having to switch contexts or just keeps the conversation going. Sort of like when you call in, you start talking about one thing with your credit card company, and then they send you over to another department, and then they send you over to another department. And it works pretty well to especially with these larger systems, to interact with these things. So yeah, this is kind of what we're working on with the system-based ones. We're also, as Darren said, we're messing around with Google Cloud and AWS, and we'll be checking out Azure. Those, we're taking an approach using the CLI where the GPT-4o just knows so much about it. You really don't need to do much else besides tell it that it has access to that, and then you can kind of constrain it with the RBAC access using the CLI from your local workstation. So it actually is a kind of a collaborative effort between the operator and the LLM working on these systems. I think there's a lot to unpack there, and it's pretty powerful. It's proving to be really useful.
So as you built this out, this is running locally, right, Bill? So it's running, the GPT scripts are all running on your laptop effectively?
Yeah, so all the GPT scripts.
Jared was running his stuff out in ECS. It was sort of like he had to deal with access, and he had to sort of give it permissions, and it was a operator in theory, right? Like, so in Jared's case, it was, I've created this agent who has almost like its own identity and its own actions that it takes. In your case, it seems like the actions are all being taken by you, and it's doing it in your name with your authentication. Is that am I accurate in understanding?
Yeah, it's like a collaborative effort. I think you see like there's like ChatGPT where you go to a window and you consult with something, you go try it out, you come back and you kind of have that dialogue. And then there's sort of the while you're coding workflow where it's like trying to read your mind, and it's injecting code and you're kind of reading and reviewing. This is more like it's like, I don't know, pair programming or something like that, where you're sitting with the LLM. And so say I just like, as the operator, I want to know, what VMs are running in the United States. I can ask that question, and then the LLM goes, oh, well, we need to go run these 4 commands. It does it all in parallel, aggregates all the information, and gives it all back to you, right? Like, so you're working together with the system. And yes, it can't do more than I could do individually. It just does it faster and, summarizes it, makes it quicker.
What are some of the more complex things you would think about using this for that maybe would take a little longer, would have been time consuming for you? For example, trying to maybe allocate costs better, or trying to, look at alerts that are coming in from DigitalOcean? Like, what do you, when you think about sort of as an individual person running their own systems, where's the biggest bang for the buck?
Yeah, it really helped dive into your bill. DigitalOcean, you can say, give me the bill for the last month, and then if it looks like it spiked, what caused that spike, and they'll keep unpacking it with you instead of having to go click through UX. In the case of AWS, we were going through, and some of the exercises we went through as part of building out the SaaS and trying to manage costs and understand where those were, we were able to make those queries very, very quickly. Or if you kind of remember in the early days of Rancher, where every Friday night, Sheng would say who's left VMs running and be able to kind of go through and shut those all down. So those types of activities from a cost perspective become super quick and super easy to do.
Do you see like the ability to do cron-based actions in these chats where you actually just say like, hey, every Friday do this, and it would have the ability to remember it? Or is that sort of more closer to what Jared did, and a separate operation that's on a trigger, and then that kicks off and fires up and executes?
Yeah, that's probably more in line with what Jared's kind of doing there. And so the difference between, you would put it on a schedule versus maybe an alert trigger, but that would make a lot of sense too. It's the same set of kind of challenges that he's facing that you'd be facing using these tools. But again, with the chat interface, when you're building the chat interface piece, it feels like that's going to be much more collaborative, human in the middle. So, I was thinking about sort of, as he was saying, if it came to the level one person, here's the recommended solution, do you want to take it? Would be like the chat workflow, right? Like, oh yeah, go ahead and do that. And then if you know that you trust that action, that button that you can push, the LLM could do that, report back the status and the results, potentially freeing up, the person to, look at the next issue while that one's happening.
It's like that's what I would love to be able to do, is kind of stitch these two things together, where it's like basically you have an alert, you do an initial analysis, and then basically kind of have a recommended action, and then you can turn that into a chat session where it's like, look, here's the context, this is what happened, this is what we think you should do, and then you start a chat, and then you allow like the kind of human to continue to go forward, or you can just confirm and deny or whatever.
So I have a quick question. So one of the things that I was thinking about with the tool that I built, and I think it's still applicable in the chat context, is memory that exceeds the context length. So in the response example we have, I restarted the service 3 times. Maybe I need to escalate, right? So I remember that I've done this action, so I'm recording it someplace, and you could use the knowledge tool for it. You could use some other log file. I think I've been wanting to play with the knowledge tool a little bit in this regard and say there's certain things we want to like chuck over here into our remember it for later space. Yeah. But I think even in the chat context, as you're rolling around from day to day, right? Like your machine restarts. Now you want to pick up where you left off. And I know that you can resume a chat, sort of in that respect, but I actually haven't looked into it very closely to see just how much of the context it persists, backwards. But I think as you go from like days to weeks to months, being able to remember things that you've done and sort of have the tool begin to grow. Have you looked at, poked around at that at all?
Yeah, so one thing I've realized, like, as you start chatting, is that like 100, like, so GPT-4 is 128K, or 128K tokens, which in regular dialogue ends up being quite a bit. It's a very long conversation. So you can actually keep a lot in the context. The trouble we have, because we've been trying to like anything that goes beyond that, throw it into RAG and then use a vector, is like we've got iffy results on that. We're really fooling around. Like the knowledge tool that we've built, it's like when you start getting into search, like indexing and searching, it gets a lot more specific. We haven't had the best results yet. So we've mostly been seeing like fooling around with kind of how we can keep as much information in the context. And so there's this new feature that I'm working on. It's on main or whatever, where you can get the whole chat context, you can get the whole chat history, and then kind of programmatically look at that. So we keep the entire history, even when it goes past the context window, and then that's available to a tool. And then that allows you to do more things, possibly, so we're fooling around with that of like, so like there's this new function in there. It's called syschat history, and it's a very, very simple tool that will just basically give you a JSON blob of your previous history within a chatbot or whatever. So that
sounds really interesting. I think the other thing that we could sort of look at, and this is, I think, doable even with the code base as it stands, is GPTScript knows when it takes an action, like when it uses a tool or something. And so you can have sort of a, instead of trying to knowledgeify the whole of the context, like the various chats that go back and forth, whenever it takes an action, like it spins up a VM or it solves a problem, like, you could sort of add that to a log of sorts that would be something different maybe than the knowledge tool even, but maybe that's an adjacent spot in the chat history that says, like, here are the things that GPTScript did as a means of storing that stuff over to the side. And then that could be either accessible via the chat history tool, or accessible in some other context, so that you can start to pull that data back in. It's similar to, I think, at least the way that I understand that ChatGPT's history works. The LLM decides when it something it thinks is important, and then it puts it over into this like little slot zone. And so it ends up being the goal being that like your memory stuff becomes very short. Like you don't really want a ton of stuff in there, but you do want to remember things like, I did this and it didn't work, right? Like, or maybe like, this is not valid YAML for this, like this thing, or like I made an assumption and it didn't go. I think that could be kind of interesting. I'll definitely take a look at that chat history though. That sounds really
you brought up the ChatGPT history, like the way they do it is like, because you realize like the way these model, like a lot of the behavior, like we're really kind of exploiting the built-in kind of personality and behavior of GPT-4. It's just extremely good, and they've tailored it a specific way, and they've also made it work really well with function calling, because they fundamentally build all their stuff on function calling too. So they have a tool, I think it's called the bio tool or something like that. It's something weird that GPT will just call, because you can ask the LLM and it'll tell you about it. Like you can ask ChatGPT like how it works, and it tells you. So we've been looking at seeing if, like, because we're using GPT-4, like what if we just give it the same one? Because I think it's like, as you said, it's like it just decides like, oh, that's an important piece of information, save it. So there's another feature in GPTScript, which is the workspace, which is like you have kind of this just temporary directory available to a GPTScript. And so you can persist that workspace across multiple runs. And so you can just, if you want to just write a tool that would just kind of persist and save that information in the workspace. Because like what we found is like a lot of this stuff of kind of like, how do I save information? Or it's like, for the most part, just read and write files. It actually works, really well. But yeah.
Guys, I want to be mindful. We're going to run out of time in a few more minutes. Okay. But one of the questions I have is just like, okay, where, or maybe this question is for you, Bill, like, where should someone start? Like, I mean, should people be building these chatbots? Should they be building agents? Or do you think this stuff is going to come together more and it'll be just turnkey? Will this be baked? I mean, is all this going to just get baked into my cloud provider pretty soon? Like, is it reasonable to expect that the CLI for AWS will be a chatbot or have chatbot functionality baked into it within 6 months or a year? Like, what do you think, like right now, what would you be doing if you were working back at, in industry to kind of leverage this stuff and make your job easier?
No, I mean, I don't know. I mean, like AWS might build a chatbot that's good at AWS, but it wouldn't work, with Google Cloud. So anyone that's, spent the last bit going to Kubernetes so that they can do, multi-cloud or something like that, I don't know how well that will help them, like whether they'd want to use each individual model or they'd want to have a single kind of chatbot with multiple tools. You know, right now, GPT-4o is just really good with command line utilities, and so I don't think it's too hard to get started with it and start, sort of with the access control constraints. Just only give it a read-only token, but let it, query things for me and be able to do that type of stuff. Or SSH. I think, I've got pretty powerful interactions with AWS in 5 lines of GPTScript and a logged in session with the AWS CLI. So, I mean, G-Cloud's very similar. So I think
possible to, can you imagine that we're looking, again, would you think about building a single agent that had access to all of the systems you were working in? Like, for example, like I want to have one thing that I'm communicating with, and has access to, my AWS stuff, but also other systems that I work in. I mean, instead of switching contacts and maintaining sort of 3, 4, 5 different chat search or agents, why not just consolidate all this into, the DevOps Darren that you want to work with?
It becomes practical. It becomes a very practical issue of like, it's the larger something gets, the more just unknown the behavior. And if you give it access to too many things, then there's more chance that it will do the wrong thing. And so like what we've been fooling around with, and like Bill actually did it in this demo, but if you're real keen, you would have noticed, is that you can build these smaller specialized agents and they can just hand off to each other. So it's like when Bill was demoing, he actually was talking to one agent and he said Kubernetes, and it just immediately handed off to the Kubernetes one. So it's like you can build more specialized like instructions or whatever. It's because it's like it's easier to kind of build the smaller things and then to piece them all together, to aggregate them, than to try to build like one big Uber one, because it just gets too unconstrained and.
But like in that, and let's say I'm working in multiple clouds, is my Kubernetes element consistent across DigitalOcean and AWS, or do I have an AWS EKS one and a DigitalOcean Google GKE one? Am I building separate interfaces to even talk to Kubernetes, or can I start to? Because I'm just imagining if I work at a company, am I having everybody go and build all these different things, or am I starting to centralize? Because even if it's not a ton of work, it does still feel like this doesn't feel like it should be at an individual level that people should be doing this.
No, I mean, I think you could specialize it per sort of, the domains could be broad but aggregated. So like you could have a common entry point, and then
I assume anyone that wants to use your DigitalOcean tool should be able to just pull it down, right? It's open source, it's out there.
Yeah,
I don't have to go build my own DigitalOcean tool. I can take your DigitalOcean tool.
Just think of it this way: is like if you go to a search engine and you say like you ask a question and it's not personalized to you, you just get the answer to that question. But if the search engine is personalized to you, then it's going to be like more relevant. So it's like if you just pick up a generic DO tool, it just generically knows DO. But what you can do is like you can give it just a little bit more information that's specific to you or your organization, and then tailor it, and then it will be much better. Because it's like, you guys use certain services or a certain way. DO is kind of basic, but like AWS, for example, is like, because, you can just tell it the specific services or whatever, or, Kubernetes, like, for example, when I do Kubernetes stuff, I typically have a prompt in there that says, prefer to use Helm charts for all operations, because I want to use Helm charts as opposed to just having the LLM create YAML and apply it. So I can tweak it. So I don't think it goes down to an individual level, but it's more like you can build a generic one, and you can like, and that's what I'm actually like. I'm working on this kind of generic DevOps kind of example of how you could, but it's like it's only so useful because it's generic. But like with a little bit of effort, you can then tweak it. And I think that's what's really interesting about that is how simple it is to tweak it, because it's like the current state of like DevOps or infrastructure is like we've kind of like all gravitated towards very similar solutions, and so we're all using very similar systems, and the AI already knows those systems, but the way that we use those systems is unique enough in each situation to make it just kind of a little more difficult. So it's like, I don't think it's useful to actually just try to create one Uber one, because it's not tailored to the way you want to do things. So I think it makes more sense like an organization or a team would build a chatbot specifically for them. And what we're trying to do is just make it so that effort of creating it is so simple. Like it shouldn't require so much effort, because like that we're seeing is like, once we figure out what we're doing, because like a lot of this is experimentation and it's the first time we've ever done it. But like once we finally settle on like, oh, look, this is what we need to do, it's a surprisingly small amount of like AI. It's a couple lines. It just took us a long time to figure out like, so like once that pattern's established and people realize like, oh yeah, you just need to put like these 3 lines in there and then that's it. And then it's tailored, so.
Cool.
So I think,
go ahead, Jared.
As just really quickly, I think absolutely cloud providers and tools are going to get smarter, and they're going to start integrating LLMs, either local or cloud-based. Like you can already see this with, Microsoft's, Copilot, or what do they call it? Windows Plus or whatever, the new laptop they got. But to Darren's point, one of the things I think that GPTScript does really well is it makes things composable. So yes, you can start with something like the Kubernetes generalized helper. And if you build it right, then it becomes a tool that you can incorporate into essentially a customized version that might be, that might have the base of the Kubernetes generic version, but then be tailored to either my organization or even my application or the platform. And so you sort of like tailor these things down to the different layers. So I think there's definitely like a place for this, something like GPTScript where it lives in that space, to where it can sort of, because one of the other sort of neat things is with like, even if the clouds start to leverage LLMs in their own thing, it will still, AWS is never going to write their CLI to be good at managing Azure, right? But you can write a GPT script that can like change contexts and have, for this application platform I might have that maybe spans both of those, I can perform operations on my application platform that maybe spans, multiple application services or even technologies. Like maybe it updates a ServiceNow ticket whenever I take some action, right? And so now I can take 2 platforms and integrate them together. And I don't think that you're going to find a single vendor that's going to make their tool smart enough to try to like start tying in together multiple services or, across vendors like that.
Awesome. Yeah. Guys, we need to kind of wrap it up, but Jared, thank you so much for joining us today. It was great to have you share what you're working on. It's really cool, and seeing sort of automated responses gives me some excitement that we're sort of beginning to get closer to, kind of adding capacity through AI, which is, I think, for a lot of teams where the big excitement comes. Bill, thanks for showing off your demo as well. If anyone wants to check any of this stuff out, if you go to just gptscript.ai, that'll take you to our GitHub page. You can just Google GPTScript to find us there as well. But you should be able to download the project, start building your scripts, give us a star. You can read all about our, kind of product enhancements as we're moving along at acorn.io, where we blog kind of every week or two as we add new features. And we have tons of tutorials on how to use these things. Bill, is there anywhere somebody can kind of play with that DigitalOcean thing if they want to find it? How would they find it?
Yeah, it's on my GitHub page. It's the DO chat repo for Cloud Nautique.
We'll put it in the comments on these videos, and I think we'll be posting a blog about it probably next week as well. So thanks everyone for joining us today. Darren, Jared, Bill, thanks as always, and we'll talk to you again soon. Have a great day.
Thanks. Bye.